Did you know that the dark matter theory proposed by Stephan Hawking in 1971 is considered to be one of the most contested theories in the spatial realm so far? But did you also know that with recent innovations such as powerful telescopes, scientists now believe that in fact, the James Webb Space Telescope might be able to at last prove Hawking's dark matter theory after all? But what is this dark matter theory all about? And who is Stephan Hawking to begin with? If you are curious to find out, then watch this video to the end. Also, if you want to know the latest on the James Webb Space Telescope, NASA news, and other space updates, click the like and subscribe buttons. With that said, let's probe right into the dark matter theory and how the James Webb Space Telescope might be proving the once contested theory true sometime soon. Coming back to the point, first things first, Stephan Hawking was a renowned English physicist, cosmologist, and author who was an expert in theoretical cosmology and held the position of Director of Research at the University of Cambridge's Centre for Theoretical Cosmology before he passed away at the age of 76 in 2018. So with the introductions out of the way, what was his theory on dark matter about? Hawking's theory proposed that the small black holes that formed early in the universe could be, in fact, the source of dark matter. He believed that these black holes, called primordial black holes, were not created by dying stars, but rather originated in the first few seconds after the Big Bang. He also believed that the high-density regions in the early universe may have collapsed in on themselves in an attempt to form these black holes. And if you didn't know by now, the largest type of black hole is a supermassive black hole, which has a mass greater than 1 million suns combined, and would fit within the diameter of our solar system. In fact, every large galaxy has a supermassive black hole at its center. For instance, just for clarity purposes, a supermassive black hole located at the center of the Milky Way galaxy is so massive that it has a mass equivalent to 4 million suns and fits within the ball of a diameter the size of the sun. In addition, did you know that the origins of black holes can vary? For example, primordial black holes are believed to have formed in the early universe soon after the Big Bang, while stellar black holes are believed to have been formed when the center of a massive star collapsed and caused a supernova. Finally, supermassive black holes are believed to have formed around the same time as the galaxy they are in, with their size related to the size and mass of the galaxy. And another fun trivia fact is that have you ever wondered what would happen to our world if it came near a black hole? The answer to this is that while it is unlikely for us and our world to get close to a black hole, as the closest known black hole to us is 1,500 light years away in the Monosaurus constellation, it is nicknamed the unicorn. However, if you were to get too close, the intense gravity would pull you in and ultimately tear you apart. This is because there is no escape once you pass the event horizon, even if you could travel faster than the speed of light, which itself is impossible. But why are we discussing these black holes, and what is their relation to this dark matter, and why was Hawking's theory contested by fellow scientists in the first place? You see, many other fellows of Hawking's disapproved of his theory that dark matter could be composed of small black holes formed during the origin of the universe, because, despite being believed to make up 85% of the universe's mass, dark matter remains unproven, as all efforts to detect it through experimentation have been unsuccessful thus far. And while fine, because there was no space equipment to probe deeper into the universe at the time the theory's contestations took place, things have taken a new turn recently, all thanks to NASA's latest space inventory, the James Webb Space Telescope. In order to test Stephan Hawking's theory on dark matter, scientists needed a powerful telescope that could see beyond what current telescopes were capable to explore. The James Webb Space Telescope, or JWST, proved itself to be that special one from the very start of its launch date. As a result, the JWST has a significant amount of time to uncover the mysteries of the universe, with an estimated 20 years of operation thanks to the amount of fuel it carries. Moreover, now that it has been successfully deployed to its location about 1 million miles away from Earth, the main question is how the JWST will work to potentially validate Stephan Hawking's theory. Stephan Hawking passed away in 2018, just before the launch of the James Webb Space Telescope. The launch had been delayed multiple times, and the cost of the project had grown to 10 times the original budget. The telescope was finally launched and deployed successfully, and it will now undergo a period of calibration and testing before it begins its observation. The James Webb Space Telescope is equipped with a large 6.5 meter mirror that allows it to observe the atmospheres of exoplanets and peer through the clouds of dust to observe the formation of new stars and planetary systems. The JWST will also have the ability to detect light from the early universe, close to the time of the Big Bang. With an estimated age of 13.8 billion years, the JWST will be able to observe the light from the earliest stars and galaxies. And just recently, during a space research program, 3 scientists, Natarajan, Kapituli, and Hasinger, have delved into the theory of primordial black holes and how they might be able to explain dark matter and resolve other cosmological mysteries. What these 3 scientists discovered, with the help of the James Webb Space Telescope and LISA, or the Laser Interferometer Space Antenna, are posed to reveal new information about black holes. They believe that the primordial black holes discussed in Hawking's theory could play a significant role in the universe by being responsible for the formation of the first stars, galaxies, and supermassive black holes. The research also suggests that these celestial bodies appeared very quickly in the history of the universe, possibly too quickly to be explained by current theories of formation and growth. According to Kapituli, the study demonstrates that by only using existing theories and not introducing new particles or physics, it is possible to solve many of the mysteries in modern cosmology, including the nature of dark matter and the origin of supermassive black holes. The scientists also believe that this theory could be tested in the near future. This is definitely a huge leap in the world of astronomy, as it can change future space discoveries that are yet to come about. They point out that the James Webb Space Telescope is specifically designed to answer questions about the origins of stars and galaxies, and the next generation of gravitational wave detectors, such as LISA, will also provide more information about black holes, including primordial ones. The researchers believe that by using both observatories, they will be able to piece together the story of the first stars and potentially uncover the origins of dark matter. With that said, what do you think about the surprising news that the James Webb Space Telescope might be able to prove Stephan Hawking's dark matter theory correct? What other theory that has been contested so far do you think the JWST might be able to prove in the upcoming years? Let us know in the comment section below. And if you enjoyed watching this video, do press the like button and tap subscribe to stay notified and keep watching amazing videos about space telescopes, NASA news, and other space updates. See you in our next video.